Welcome to beautiful Munich in June of 2023. Laser is back in force. We are looking forward to resuming the 2-year cadence that laser has always had so that we can continue bringing you new news, new products, new technologies to help your applications advance. Here's an example of something we brought out a few years ago with this introduction in 2026. This is our F712 system. It was the first fast multi-channel photonic alignment system in the world. It integrates some unique algorithms that allow it to do the following. With silicon photonic devices, you have multiple inputs, multiple outputs, multiple channels that require multiple alignments in multiple degrees of freedom. That is a real challenge for conventional alignment technologies. You can do it, but it can take up to 2 minutes of time or even more to do the job. With this device and our unique algorithms, you can perform this multi-channel, multivariate alignment and get the whole job done in about 1 second. So that's a factor of 100 times faster than legacy technologies. So this has proven to be an enabling technology for photonic manufacturing, test, and assembly. It starts at the wafer level, wafer probing. It's very important to identify which chips are alive and which ones are performing. And then it proceeds throughout the packaging process where test and assembly must be performed in multiple steps, and each step typically requires alignment. So if each alignment takes a couple of minutes, that is very expensive. So when you get it down to 1 second, that is something that is sustainable for the photonics industry. And the photonics industry needs that because all the new applications that are coming out. The first of them were driven by our appetite for data, for streaming media, social networks, trading selfies among ourselves and our families. So all that data drove the advent of the data center, these mega-scale server farm. And photonics, silicon photonics was what has been deployed as the most scalable, efficient, capable, and green approach for sustainably keeping pace with the data requirements that people have. In addition to that, we're starting to see new applications such as LiDAR for autonomous vehicles and optical cables, quantum computing, optical computing. Optical computing is fascinating. It's when you perform sophisticated calculations and inferences in the time it takes the photon to traverse the width of a chip. This is what the future holds for us, and the photonics industry must keep pace. That means that, well, it's been calculated that over the next several years, the overall throughput of produced product in the photonics industry has to scale by about 3 orders of magnitude. That requires speed, and that is why this is so important. And that is why the news is we have taken those unique algorithms and we have built them into the ACS controllers that we use to drive our industrial systems, modular systems such as this air-bearing system, but also any travels, any type of motion technology supported by the ACS platform, including mixtures of technologies, can now partake of that efficient alignment algorithm. So we expect that this will usher in a new chapter for even more efficient, more capable, more scalable, economically optimized manufacturing, test and defend it for the future of photonics.